Question 6. So, state the range of f. Well, think about this first term, e to the power of x. The very smallest that can be is approaching 0. So, if you take a very big negative value for x, e is approaching 0 but never quite reaching it. So, the range of f is always just going to be greater than 2. So, f of x is greater than 2. Now for part B, find f gx, so we take g of x and we pop it into f. So we're taking our ln x and popping it into the f function. So this goes into this, and e to the ln x is just takes you back to x. So we're left with x plus 2 being the function in its simplest form. Now for part C, find the exact value of x for which f of 2x plus 3 equals 6. So this is the function f of x equals e to the power of x plus 2. So we're saying if we substitute 2x plus 3 into this x value, it equals 6. So e to the 2x plus 3 plus 2 equals 6. We'll take away 2 from both sides, gives us this. Now, remember when we multiply we add the powers, so breaking this down we can have it being the product of these two, e to the 2x times e to the 3. Now if we take logs, or to the base e, so ln, and then do the power rule at the same time, we have 2x ln e plus 3 ln e equals ln 4, ln e equals 1. On both occasions, so 2x plus 3 equals ln 4. Rearrange, we get x being ln 4 minus 3 over 2. Now for part D, we're being asked to find f to the minus 1, so the inverse function of f. So our function of our f of x is e to the x plus 2. So we really just need to change the subject here and make x the subject. So let's kick off by just saying let's let y equal e to the x plus 2. Rearrange to make x the subject. We get x being ln y minus 2. So our inverse function of x is ln x minus 2. Now the domain of our inverse function of x is the same as the range of f of x, which we found out back at part A. So we've got x being greater than 2 again. Now for part E, we've got to draw the two graphs. So start off with plotting f of x, which is just e to the x plus 2. So transformation of graphs, this is outside the function, just adding 2 to our basic function. Our normal e to the x graph is shaped like this, passing through the coordinate 0, 1. So this just adds 2 to all the y values, so just shifts this up 2. So it's crossing the axis at 0, 3. So there's our curve y equals f of x. Now remember, to plot the inverse function you just need to reflect this in the line y equals x. So whereas our asymptote to start with for our f of x is y equaling 2, obviously it's shifted up 2 from our e to the x function, our asymptote for the inverse function is going to be x equals 2. Rather than going through 0, 3, it would go through 0. So this is our inverse function here.